Good afternoon again. Welcome to our roof runoff management webinar. Again, my name is Hamid Farhani. I'm a water management engineer here at East National Technology Support Center in Greensboro, North Carolina. And I will be moderating this interesting webinar. What is more interesting than capturing water from our roofs in this era of water scarcity? I'm expecting this would be an interest for folks in the East and folks in the more semi-arid environments. With that, I would like to introduce our main and only speaker, Mr. Bill Ray. Bill is an agricultural engineer with expertise in the environmental engineering field. And I think that's as much as the introduction he wanted me to provide. He has a lot of other expertise. But with that, I'm going to stop here. And Bill, please.
Thank you, Hamid. We'll have a couple spots in here for questions as we go on. One about halfway through and one at the end. And questions will be handled through the online system. We'll get to the end. We may switch and allow some voice questions. All right, here we go. So what we're going to cover this afternoon, we're going to talk about basics of planning and design for a roof runoff system. Talk a lot about sizing gutters and downspouts. Talk a little bit about some trench drains as well, gutter tile drains. And we're also going to talk just briefly about some storage of roof runoff for other useful purposes. It's all based on the NRCS Conservation Practice Standard 558 roof runoff structure. And so we're going to be basing, this presentation is based on this practice standard primarily. So roof runoff structures are structures that are used for collecting, controlling, and disposing of runoff water from roofs. I mean, that's what they're there for. So why would we want a roof runoff management system? Well, for our purposes, the primary reason that we use roof runoff management is to keep clean water clean, especially in animal waste management situations. You see here from the picture, you've got a lot of the roof area of this site is actually contributing to a potential water quality problem. The added roof runoff is mixing with animal waste, and then it's become dirty water. If we can keep that separate, then we've reduced what we have to treat or take care of. Another way and reason to have it is that we can actually, in some cases, it will improve waste handling. For example, if you have a roof that runoff leads to a lot, and you are scraping that lot for removal of manure by taking the rainwater out of the equation, you're left with a material that's easier to scrape and handle. In this picture is a pretty sloppy mess that could have been reduced had rainwater been kept out of the equation. Reduced water storage requirements for waste storage structures. I mean, this is really a big one. In the CNMP training that we provide, we have an example that I'm going to share with you about roof runoff and how that can impact a waste storage design. Here we've got a dairy, and we've got a significant amount of roof area. And in this example farm, we had about 10,000 square feet of roof, and then some other impervious areas, concrete, roof feed bunk, and silage bunker. Total of about 30,400 square feet of area. If we were to take out the roof runoff, divert that somewhere else, we've cut our impervious area by about a third, and that can really impact the amount of water that we have to deal with from areas outside of the dairy cow areas themselves. For example, if you were to just put gutters on this example, you start out with about 116 cubic feet per year of runoff from the whole area, if we didn't have gutters. When you install gutters, now you're getting down to about 78,000 cubic feet. And that's a savings of 38,000 cubic feet of clean water that you've removed. You don't have to treat that. So, in this example, you've removed 285,000 gallons from the system. What does that mean to a producer? And this is a selling point that we use when we're talking about installation of gutters and what's the benefit to the producer. That means 10 to 12 hours less pumping per year. It means that the storage period, you can go, if you have an existing pond, you can increase your storage period from 120 to 150 days. Or if you're putting in a new waste storage structure, you reduce the required size. And gutters are fairly low cost. We're talking somewhere between $6 and $7 per linear foot to install gutters. So the cost and payback for gutters is really pretty good. And this is how we should be approaching producers on the benefits of putting in gutters in animal waste systems. So, why roof runoff management? Keep clean water clean, improve waste handling, reduce waste water storage requirements for waste storage structures. And now we've got another reason that's coming in here recently: collect and store roof runoff for other uses. Now, I say recently because it's fairly recently for us in the East that we're doing some of this. We had a CIG in Alabama a couple of years ago where they're collecting roof runoff for reuse for poultry. I believe they've done the same thing, or talking about doing the same thing in Virginia. Out west, this has been done more in the more arid areas. Usually, you don't think of the East as being water poor areas, but there are places where groundwater is not as available, or there's some permitting restrictions, and capturing roof runoff could actually help with those kinds of problems. Here's an example of a livestock watering facility in Georgia where roof runoff is captured and routed to a watering trough. Here's another example from Texas of roof runoff water that was captured and then used to grow vegetables. I will say this about irrigation water. You can get a significant amount of water off of a roof, but you probably aren't going to be able to irrigate, say, a 100-acre cornfield. I mean, there's a limit to how much water you can get off. But certainly, if you had a small vegetable crop, you could use to augment the water available during, say, dry times and improve harvest. So, what are gutter systems and roof runoff management? What are we based on? In NRCS, our design guidance comes from Chapter 10 of the Agricultural Waste Management Field Handbook. It's got some information in there about why we roof gutter. There is some design guidance in there as well. Here we see a figure that's talking about using a roof gutter and taking the water and routing it away from the production area of an animal waste management area. Let's talk a little bit about, let's move into design. In Chapter 10, it talks about gutter capacity and how to size gutters. The equations are here for you. I'll just tell you, it's fairly simple to calculate. And at the end, the presentation and the handouts, I have included several spreadsheets that were provided by states that I think are pretty good. Many states have these. Definitely check with your area engineers to find out what your state is using. But most of them are based on this concept. You have a cross-sectional area of the gutter. You wet a perimeter using, and you use basically Manning's equation to calculate gutter capacity, and this is based on a gradient of the gutter of about 1/16 inch per foot. There's typical gutter sizes that are out there. This is a K-type gutter. There's galvanized. There's also aluminum standard sizes. Rainfall, another important parameter for sizing systems. When we think about rainfall, it's two different storms that we're designing for. The 10-year frequency 5-minute rainfall is the design that we would use for non-animal waste systems. For animal waste systems, we use the 25-year storm frequency, the 5-minute rainfall. That's just to size the gutters to make sure that we're capturing the 5-minute rainfall for a 25-year storm is basically the maximum that you're going to see that gutter needs. If it can carry that, then it's going to be able to carry that 25-year, 24-hour storm away from the production area. So, that's why we use the 25-year frequency for animal waste systems. So where does this data come from? Chapter 10, Appendix B, has got maps in it for these 25-year, 5-minute rainfall in inches. It also has a map for the 10-year, 5-minute rainfall. Now, I do need to mention that the data that was provided in Chapter 10 is pre-NOAA 14 update. NOAA 14, as many of you are aware, is a recent update to our rainfall data that's being done by NOAA, and the states that have, many of the states have already had this completed. The Northeast states have got the data now. NOAA hasn't finished processing it, but they can still get to the data on a website. These states will be converting over to using NOAA 14 data instead of using Chapter 10 of the Ag Waste Management Field Handbook, and we hope to eventually get those graphs and data in Chapter 10 updated with new data based on the NOAA update. Here's an example of Iowa and rainfall data for that state. Now, if you're in Iowa and you think, well, I've never seen that map before, it's because this is kind of a test map that we have recently created to kind of see what maps might look like if we update Chapter 10. All right, gutter slope. 1/16 per foot is kind of the standard. It works out to a little over 6 inches of fall per 100 foot of gutter. So why is that important? Well, you need to think about, does the building itself have any slope? And what's the width of the fascia board that you're attaching the gutter to? If you're going to slope and your building is level, your fascia board has got to be wide enough so that over the length of the gutter you can have that slope. So it's something that you have to think about. And why do we have slope on gutters? Well, we really don't want to have standing water in our gutters, so you want to have slope. And more slope also increases the capacity. So later on, when you're talking about sizing gutters, there's a trade-off between the slope of the gutter and the capacity, and when you compare that to downspouts. It may be that you need to increase the capacity of your gutter, and without increasing the size, you may be able to do that by increasing the slope slightly. That all depends on, like I said before, what kind of length of building you're talking about, what's the width of that fascia board, just things that you have to think about. Let's talk a little bit about downspout capacity. So this is a trading and balancing act. You look at your gutter capacity, and you're also going to be looking at your downspout capacity, because one of those two is going to be the controlling factor. Downspout capacity is also a function of the cross-sectional area. It's the cross-sectional area of the downspout. The depth of the gutter has some impact on that, and here's the equation. Here's an example of a gutter downspout, and as you look at this, you may think, wow, I've never seen a double downspout coming out of a roof cover. Well, you wouldn't typically see this on a residential building, because those gutters are not designed for, say, that 25-year storm. But in gutter downspouts, you're limited in how big of a gutter downspout cross-sectional area you can have because of the bottom of that gutter. So sometimes to increase the downspout capacity, you put in two downspouts, thus doubling the downspout capacity in one spot. Another thing to notice in this particular picture is you'll notice the two downspouts come down, and there's kind of a conversion point of the funnel, and it's going into a circular pipe. So you got to make sure that the circular pipe that's down below also can carry the required flow rate that you're getting from the downspouts up above, or what those gutters need what those downspouts need to carry based on what the gutter is bringing to them. Downspouts, like I said, must not exceed the bottom width of the gutter. You want to have supports for downspouts at the top and bottom, and have intermediate supports every 10 feet. Lateral downspouts, which means if you have a downspout that comes down a little bit and then moves laterally before coming down to the ground, those lateral downspouts need to be supported more often, at least every 5 feet. Protect downspouts where animals or equipment can damage them. Here in this picture, these downspouts are in an area where cattle have access to. Cattle could easily dent aluminum or galvanized steel downspouts. So what you do is you put those discharging into a steel pipe or Schedule 40 PVC or some other rigid pipe that can withstand the animal or other equipment bumping into the downspout. In terms of the number of downspouts, first of all, you have to figure out what's controlling the gutter capacity or the downspout capacity. Once you determine that, you can then move on and look at the area of roof served by your gutters and your downspouts. And what this does is it will tell you how often you have to have a downspout for your roof system. So I put this picture in here because as I'm looking at this one, it looks to me like this one definitely wasn't designed as an animal waste system. You see two downspouts on this fairly large building on either end, and this probably wouldn't work if you were designing for a 25-year, 5-minute type of rainfall event. So let's put this into a little bit more perspective. When you're planning, what you're going to be doing is you're going to be adding up your length and your width of roof so that you know how much area you have. You're going to figure out what the area served by your gutter or your downspouts are, and in this example, I may be able to serve, each downspout may be able to serve 1/4 of the area of that entire roof, so I'll need 4 downspouts. And that's per side. Sometimes your downspouts are going, and your width is going to be controlled by the structure itself. If you have a long distance between points where you can bring down a downspout, you're going to have your downspouts being is some increment of those spacings of your roof post. So that's something you consider, and this is when you start dealing with these type systems, or when you end up having to play the game. Do I increase gutter size, or do I increase the number of downspouts or downspout size? So these are when you end up having to do a little bit of a balancing act when sizing the gutters and the downspouts. Let's talk a little bit about gutter outlets. Obviously you don't want to cause an erosion problem where your gutters are outletting. In many of our animal waste situations, we're going to outlet to an underground outlet and take that water to a safe place. But there are splash guards that are made for this purpose. In this picture, we're outletting onto a gravel surface. You could put down rock riprap or some rock to dissipate that energy coming out of the gutters. But you want to make sure that there's something there that you're not going to cause an erosion problem. In the example we gave before, we could use an underground outlet and then take that water to some sort of outlet, whether that's a waterway or whether we're going to take the water away from the production area and then just allow it to be discharged onto a vegetated area. Underground outlets can collect, will collect water and can collect water from multiple roofs. They can be routed around a facility. You size the underground outlets much the same way that you size any underground outlet. You're going to look at the controlling discharge coming into them, which is, what's the size of the roof, what's the peak coming off the roof, and that are coming in at different points, and make sure that at each point you have a downspout coming into your outlets, that you have enough capacity to carry all of the discharge at that point. And the same is true of these lateral collection pipes. You want to make sure that the lateral collection pipe, as you're moving down the pipe, you have the capacity necessary to carry all the flow at that point. Here's another example where you've got a gutter that's coming down and you've got one lateral pipe that's servicing the side of this particular facility, so that you can come down and only have really one entrance point into an underground outlet. I do want to mention, you don't always have to route roof runoff to an underground outlet. In this case, the water is routed to where it's needed. There is a reception pit at the end of the barn where dairy waste collects, and in this case, water being added to the system was not a concern, and that water, adding it to the manure here, actually makes it easier to pump and move that slurry. All right, we'll take a break here for a second and see if we have any questions at this point. Hamid, we got any questions?
Yes, we have been getting some good questions. I've been trying to reply back, so I kind of communicating on the side. But one came from David, and I thought it was interesting. He said, is captured rainwater actually considered clean? So I wrote back and I said, well, it all depends what's our definition of clean. If the true definition of clean is safe enough to be consumed by humans, but is it safe enough to be consumed by humans? I replied to him, that's probably not a safe assumption. And I have seen, for example, the example you offered in Alabama, they use UV sanitizers to sanitize it. But my professional call would be, I would test it, see what kind of roof is coming from, and Bill, if you wish to, it's actually your question.
Right. Yeah, we're going to get into that a little bit later in the presentation. I'm going to talk about roof water harvesting and requirements and a little bit about that then. But you're right. There are, rainwater by itself is very clean. When the rainwater hits the roof, it can pick up contaminants, and so you may even get some fecal coliforms that are in that roof runoff water that you probably wouldn't want to drink straight.
Okay. And next question now, I'm going to paraphrase all this. It's from Punya. He had a good question. He said, you talk about gutter and downspouts, but how do you calculate how much water is collected on top of the roof structure? I reply with my rule of thumb that I always use, and that is, for inch of rain on 1,000 square foot of surface, you get about 600 gallons. So that's my rule of thumb, 600 gallons per 1,000 or 0.6 gallon per square footage per inch of water. Obviously, it depends on the slope and all that, but there are various...
Yeah, I have another number later in my presentation. It's probably a metric, but very similar.
Okay.
Would
you like to entertain one more question?
Sure, one more.
This is from Mike Martin. It says, do you have any data, this is interesting, do you have any data on how far below the edge of the roof a gutter can be before the runoff shoots past the gutter? How far can we put the gutter before the...
We have a graphic that I'm going to show later on that really talks about lowering gutter for things like to avoid snow. And that's the only thing that I've seen in the literature on that particular question. But I think what Mike is trying to get to is you want to make sure that the gutter is wide enough to be able to capture that runoff, especially if your gutter is down a little bit. You don't want the water to overshoot the gutter.
Overshoot. Okay.
All right, let's move on. All right, so some other things to consider when you're looking at a site. What are you going to attach your gutter to? Are the rafters there to attach to? Are the fascia boards in good condition? Because you wouldn't want to attach a gutter to a rotted board that's going to need to be taken care of. Is the fascia board stout enough to be able to handle the load from a gutter? And I say stout enough. Is it a 2-inch board, or is it something that's there more for aesthetics and not really wouldn't really be load bearing, a 1-inch board? Some other things to think about, and we're going to get into this a little bit more, is when you attach the gutters, there's for residential, a lot of times you'll see what they call a spike and ferrule used to attach gutters to the fascia board. And many times when you have long runs of roof, these don't work very well because of the expansion and contraction of that metal. And for a 100-foot run of roof, you could have almost a couple inches of movement of that metal from just the expansion and contraction, and that expansion and contraction will actually work those spikes out. In terms of roof gutter support spacing, typically 32 to 48 inches, 32 for aluminum, 48 for galvanized steel spacing. Those will be closer in our states that are dealing with snow loads, 18 to 24 inches. Another very important fact is that all the gutter components must be the same metal type to prevent electrical corrosion. You wouldn't want to mix aluminum and, say, galvanized steel, because you could have you will have a problem caused by those two metal types coming together. So, as I mentioned, try to avoid the spike and ferrule because it can be pulled out due to that expansion and contraction. Some typical gutter hangers that are out there. Here's they call them hidden hangers that ride on the inside of these K-style gutters, and you've got a bolt there that can be screwed into the fascia board. You can also use roof straps to attach to this hidden gutter hanger. Another thing that is to make sure that these gutter hangers are stout enough to be able to carry the load. And this graphic is just showing you, make sure that there's reinforcement and ribbing in that gutter hanger, because you wouldn't want the hanger itself to bend. Sometimes your fascia board is not perpendicular to the ground. It's kind of in there at an angle, and so you'll need to use a wedge of some sort to make the gutter sit properly. There's other types of connectors, wraparound straps. In the picture on the left here, there's a strap that's going into the hidden gutter hanger, as well as a wraparound strap. This picture happens to come from Wisconsin, where they are dealing with significant concerns about snow. Other types of support, your rigid support, you can have brackets, you can have a wooden type of brace like shown in the right. Some of these brackets are fashioned to fit your particular situation. So the standard does talk a little bit about the gutter material itself. Aluminum gutters and downspouts should have a minimum thickness of 0.027 inch, and galvanized steel gutters and downspouts should have a minimum thickness of 28 gauge. That's pretty much industry standard. And again, don't mix metal types. I will mention that in some parts of the country, you can see wood still being used for gutter, and the standard does call for if you have a wood gutter, for it to be free of knots. Some other gutter materials that are used, you can see copper gutters. But typically, those are obviously that would be a very pricey gutter, and you would only see that in a special circumstance where you had maybe some agro-tourism going on and somebody wanted to really dress the place up. It's pretty much a residential type of gutter. Vinyl gutters are also out there, but I don't think you're going to see them used in an agricultural setting from the standpoint of lifespan on those gutters, as well as their carrying capacity. Let's talk a little bit about an alternative to gutters, and that's the gravel drains. You hear them called a bunch of different types of terminology: infiltration channel, ground gutters, tile roof drains. Basically, it's the water, the drip line comes off the roof and will hit a gravel area, and at the bottom of that gravel area, you've got a drainage tile that's going to collect the water. So the water runs into the gravel, infiltrates into the gravel to the underground outlet. The subsurface drain is at the bottom of that. And here's another picture, and if you notice, the roof line comes out, and where the water hits the ground, you can see where that action has actually created no grass is growing right where the water is primarily hitting. In the most case, normally we want to see about a 12-inch of overhang before you got to that gravel drain. And here's what it looks like if you were to look at it a different view here. You've got the subsurface tile drain at the bottom of about 2 foot of gravel. And the gravel is poorly graded so that the infiltration into that gravel is very high, and that should not be a limiting concern. Poorly graded gravel. You want to size the subsurface drain to carry the design rainfall, at the peak rate. Same as you designed for the gutter capacity, you're going to make sure that your gravel drain can carry that same capacity. And another important point is if livestock have access to the area where this gravel drain might be, you want to exclude the livestock, because one of the purposes of this capturing roof runoff is to keep the clean water clean. So here's a schematic showing putting up a fence and a curb to keep water from a production area away from this gravel drain that you've installed. Let's move on and talk a little bit about snow and ice. Here's the picture talking about how gutters should be placed below the line. And this gets a little bit to the question that Mike had. You want to make sure that you have the gutters able to capture the runoff from the roof. But if you're in an area where you have snow and could have snow and ice sliding off the roof, you want to make sure that that's in a position where that ice and snow will miss your gutters. So here's a diagram. I think this originally comes from the Midwest Plan Service, but you'll see this particular diagram in a lot of different places in literature if you go out and look for design of gutters. Snow guards. The only thing I'll say about snow guards can mitigate that sliding of snow off of a roof. You wouldn't want to add snow guards to an existing roof, and the reason for that is they will increase the snow load on the roof. And so you wouldn't want to, unless the roof had been properly designed to carry that added snow load, you wouldn't want to change the loading on that roof. I did find this interesting. Maine has what they call a snow-resistant gutter, basically a slot that they created at the end of their roof that allows rain to go down and hit their gutter, but snow will slide off. So I found that interesting and thought I would add that here. Let's talk a little bit about PVC gutters. You will find some producers that choose to make their own gutters from PVC. And a couple things about that. UV resistance is key. You can either buy UV resistance PVC, just have the additive put into it, or as an alternative, you could paint the PVC. If you don't do that, what's going to happen is that your PVC is going to degrade. It won't be but a very few years, and your PVC will get brittle. So you definitely want UV resistance. I've included in the handouts a PVC bracket that can be fabricated for holding up PVC, as a PVC gutter. Here's some slides where the producer has taken the PVC, basically cut it in half using something like a table saw. You'll notice that there's even a T that's used to attach the gutter to the downspout. You can even cut in half 90 degrees. Here's a picture of the bracket, and this came from Vermont. And here we've got where a downspout trash guard was installed. And trash guards in gutters are important because you can get leaves or debris. In this case, they talk about silage blown from a nearby silo onto the roof could end up in your gutter. And this particular picture points out using lag screws into your rafter, in this case, And lag screws, would be good because they're going to be more stable than a nail. Getting back to the idea of the spike and ferrule and not wanting those to work their way out. Here's another picture of gutter on a bracket, and this one kind of illustrates a little bit of how the bracket is moving down so that you can control the slope of the gutter. And there's a picture of the PVC gutter at the dairy. And the note was this gutter system is over 12 years old and still working. So PVC gutters do work. I will state, check with your state and see if PVC gutters are allowed or not. I wanted to mention real quick that there are, I've talked so far about the NRCS method for designing and sizing gutters. Many gutter manufacturers have their own websites and have their own gutter sizing tools. Here's a roof slope card that's used by one of the manufacturers. And the only thing that I'll caution you about using the manufacturer's websites and their gutter sizing is several of those that I looked at didn't use the 25-year, 5-minute design storm like what we would want to use for ag waste. So just, if you're using one of those, just be aware of that part of the equation, that what you're designing for. Let's move on and talk a little bit about rain harvesting. If you're going to use gutters to capture roof runoff and then try and capture and reuse that water, there's a few things that we need to think about and know. Rainwater in and of itself is one of the cleanest sources of water in nature. However, after that rainfall water has come in contact with a roof and gutter, it's no longer clean. There has been some research to show that roof runoff can contain fecal coliforms. It can contain some contaminants, bits of trash that have been blown onto the roof and made it through whatever screen you may have put on your gutters. So one of the ways around this is diverting the first flush of rainwater away from your storage. And really, it only takes just a few millimeters of that first flush to get rid of a majority of the contaminants off of a roof. So just something to know. I think I have a picture showing one of those here in a few minutes. So cisterns and rain harvesters are something that's been around for a long time. You basically need something to catch the rain, something to store the rain, and some way to control use of the water. Here's an example of a first flush diverter. If you look at the picture on the right, you'll notice that the downspout comes down, and it comes down, and then there's a plug at the end. So what happens is the first amount of rainfall that comes down goes down the gutter, is stopped by the stopper. Once that pipe fills up, then the water is diverted and goes into storage. So the dirt and the contaminants that first wash off the roof are captured in the pipe. Cleaner water is then put into the tank. Filtration is probably still going to be needed. How much water can you get? Here's an example that John Fripp gave me. It talked about when 1 millimeter of rain falling on 1 square meter of a roof will result in about 0.8 liters of water. That's when it's hot. When it's cooler, you can get 1 liter per 1 square meter of roof. I've seen some other examples that are out there that you can get some tremendous volumes of water from a very minimal sized roof. It's a trade-off in terms of if you're going to use the water for, if you're going to store, do you have more storage to capture all the rainfall, or because then storage gets expensive, or do you have less storage and are more trying to bridge the gap during drought times? So there's a little bit of a trade-off, and then you're going to have to decide what kind of time step you're looking at. Anyway, so you can get a fairly significant amount of water off of a roof. Here's the picture from Alabama, from that CIG, where they're capturing roof runoff off of a poultry house and are going to reuse that. They take that water and they did find that it was pretty clean water when it came off, cleaner than they expected. I heard Jeff Porter, who was in charge of the CIG, was just telling me that the research found that they actually had more contamination from the algae growing in the tanks than they did coming off the roof. This is showing the same system. They've got some pretty big capture going on here to get water to that tank. And here's another one, similar case, capturing roof runoff for use in poultry drinking water, and they've used a screen to kind of filter out the water as it comes off the roof. Another picture that John Fripp gave me is this small system where you've got a little bit of a roof that's going to provide a little bit of drinking water. I think John was using this as a demonstration in Afghanistan as a way to provide some drinking water for in a very arid region. I wanted to include something in this presentation about rain gardens, but I just don't have time in this particular presentation. I did add a handout from Iowa on rain gardens, so I encourage you to, if that's something that you're interested in, to take a look at that handout. I wouldn't be a good engineer if I didn't talk about O&M briefly. Removing leaf and twigger litter, inspect and repair loose components, inspect drain, gutter drain if you have the rock infiltration drains. Make sure that you don't have something that's blocking the flow of water into that drain or diverting flow away from it somehow. Inspect outlet pipes and make sure that you have animal guards would be important in those outlet pipes, and ensure that they are free-flowing. Here's my levity for the presentation. Here's my gutter pre-government shutdown, and here's my gutter post-government shutdown. So somebody's going to be watching this presentation 5 years from now, and they're going to say, what in the world is he talking about? Just talk to somebody who's been around the agency for a while about October of 2013. And then you'll get it. All right, something else. Here's a picture of gutter that's obviously not been maintained, and you see the little plants that are actually taking root in that gutter. So, gutter maintenance is important. A few more things to talk about. I've talked about gutter design and a lot about systems. So this is a kind of a way to review and some things to think about if you're making that site visit. Talk to the producer. Some of the things that you're going to think about in inventory while you're making that site visit. Some things that you want to make notes of. What are the lengths and widths of the roof that are involved? Look at the building ease. Can gutters be easily attached? Is the fascia board, is it good enough to attach gutters to? Is it thick enough? Is it in a good enough condition? You know, is there signs of rot? Is that something that's going to have to be replaced first? How wide is the fascia board? You know, if you have really longer lengths of building, you know, is there any slope to the building itself, any slope to the roof? Consider possible downspout locations. Remember, you got to bring that downspout down and you got to attach it to something. So if you have you know, long open spots, or you have limited posts, like that one picture that I showed earlier, you want to make sure that you're taking that into consideration when you're designing your downspouts. And then think about, could you do a tile outlet? You know, could you do a gutter drain or an infiltration drain? Is that a possibility? Is there room for that? And can you keep livestock away from the eaves of the building? Can a tile outlet be easily installed, or are you going to need to break concrete to put one in? You know, if that's the case, it may be better to run a lateral collection line down the length of the building, so you only have to go down into the underground outlet in one place. What are the downspouts outlet into? You know, is ice damage a factor for where you're looking at? Is it going to affect gutter lifespan? Are long slopes present? Can I use a rock trench? And will livestock have access to the site? These are all things that you want to make notes about when you're doing your site visit. I want to take a minute and say thank you to some folks that sent me information to give this webinar. Had a bunch of folks that sent me spreadsheets. A number of states had spreadsheets. I included 4 spreadsheets in the handouts. And primarily, don't be offended if I didn't use your spreadsheet. I tried to pick spreadsheets that were well documented and easy to use, and use the methodology that's in the Ag Waste Management Field Handbook, Chapter 10. Ohio and Florida had very simple spreadsheets, just size of gutters and downspouts. Indiana's and Wisconsin spreadsheets went into more detail, sizing the tile drain outlet pipe, providing added sheets for things like specs. So these have some very nice features. Check with your area engineers to know what they're using, what they want to use, and these are for taking a look at if you don't have something or you're looking for a tool. I also included some handouts from Wisconsin. Had some great specs, and a lot of the pictures came from them. Maryland has a gutter design manual that's included. Just be aware that the rainfall and a lot of the charts that are in that manual are specific to Maryland rainfall. But there was really good information in there. Vermont had some really good information that they gave me, especially on the gutter drains, the tile outlet drains. Iowa, the rain garden handout, and I also included a small farms handout for talking about benefits of gutters for handing out to folks. That came from ENTSC. I want to say thanks for some pictures. John Fripp, Alabama, Wisconsin, Pennsylvania, Vermont, Maine, all provided me with great information. You know, I may have received information from others, so I want to say thank you to you too. I had a bunch of people that sent me information. Thank you to everybody who did that. If you need even more information, I will point you to Missouri Extension website. Their WQ322 page has got some good information on it as well. So with that comes at the end of my presentation. So let's see if there's there's any other questions that are out there.
Thanks, Bill. Great presentation. Yes, we have few. David wrote back. This is when you suggested that if there is any interest in what is called rain gardens, he wrote back. He said he's very interested, and if our center will consider that as a future webinar. I wrote back that I will convey that to our webinar committee for consideration. There were a couple of questions, kind of follow up from Punya and Laura, and they're mostly interested. She wrote, she said, we have very steep roofs. We have old barns with a steep roofs, and how do you, so the question is regarding how do you calculate the capture of the rainfall. I just briefly wrote back, I said I will look at the footprint of that slope and then go from there, but if you'd like to add to that.
Yeah, I mean, it's a trade-off from the projection of the water roof to the gutter, and you know, are you worried about, you know, is NOAA consideration or not? Graphic in there that showed, I showed that. I do know that some of the gutter manufacturers that out there, slope of the roof itself is one of their design considerations, but it's not really in our Ag Waste Management Fuel Handbook.
I have seen some online calculators, and so you could put in the footprint, and but in any case, here's another good question. It says, what are required slopes and roughness coefficient for corrugated plastic drain pipes? I guess roughness coefficient. This gentleman, Jeremy, is probably thinking about Manning's equation, and
right. I mean, that's a look-upable item. It depends on whether you have the smooth pipe inside of the corrugations or not. I haven't seen anybody. You know, a lot of those pipes are. I would expect you'd use the smooth on the inside version. I mean, that's Manning's in for those pipes is a look-upable thing.
Right.
For a smooth pipe, it'd be .012. I think it was a slide in here that said it'd be typical for a smooth surface.
Okay. Next question is from Kip, and he says on rainwater harvest, first flush based on what frequency? Seasonal or weekly or what?
Well, the little bit of research that I looked at didn't get specific. They just the study that was done, they captured rainfall off of a roof, and I believe it was done in a Midwestern state. I don't remember which state, but it basically showed that most of the contaminants that came off very quickly off of a roof.
Okay. Punya has a follow-up question on rainwater capture off a roof. He says, if I want to use this to provide livestock water in a pasture, I come up with my water requirement, and now how do I size up my elevator structure to provide that volume of water to me? So you kind of have to work the problem backward in a sense.
Right. So the way that you would do that would be, you know, there's a couple different ways that you could do it. If you're familiar with the SPA model, you could set up a SPA model run that basically handles that question. If you're not familiar with the SPA model, you could, you know, a coarser way to do it would be to take a monthly time step and calculate the amount of rainfall that you're going to get on a monthly time step. And what you'd want to use is a 30-day curve number for that. You could get those numbers out of the AWM computer software that we use for sizing animal waste management systems. If you just didn't include any waste and just did just the roof, You could find out how much water you were getting on a monthly basis, and then size your storage so that you would capture enough water for a month for your driest time period. And likely, that's average. So, you're looking at an average year, sizing for an average year. You may want to add to that some safety factor to try and cover drought years, or if you want to be really sure that you're covering drought years, then you're going to have to go to a simulation like a SPA model, or we used to have a computer software program called ResOp that unfortunately is DOS-based, so I think we've lost that, but you could use that. It was a monthly time step type of reservoir sizing software.
Well, Bill, I don't have any more questions here. If I have missed any questions, please feel, or if you have any more questions, feel free to email Bill. I assume that would be fine with you. And I don't have any more questions. So, Bill, if you are finished here, I guess we have reached the end of our webinar here.
Right. Thanks, Hamid. And take a look at those handout materials. If you have questions, certainly feel free to give me, an email or a phone call.
Okay. I just had one last question came through. He said, how do we get a hard copy?
Let me chime in on that. The presentations are available at conservationwebinars.net. So if you go back to the web page you used at conservationwebinars.net to launch this live event, there will be at the very bottom, scroll down to related files, and you'll see Bill's handouts that are presented as a zip file, and the presentation is presented as a PDF file.
Thank you, Holly.
Yep. So I guess if we're kind of wrapped up, I'm going to invite everybody back to join us on November the 12th at 3 o'clock for pastured poultry and conservation planning. We'd love to have you come back on November 12th, and if not, then we'll see you the next time that you come back. So thank you, everybody, and Bill, thank you for your presentation, Hamid for moderating, Emily for helping us from AT&T, and to Daryl Outlaw with Southern Regional Extension Forestry. Thanks, everyone.